No nation which expects to be the leader of other nations can expect to stay behind in this race for space.
This first commercial flight is a research mission conducted by the Italian Air Force, featuring human researchers and payload experiments.
We're able to further the technologies and the research that end up helping to better human life here on Earth.
Commercial spaceflight is changing what access to space means.
Release, release, release.
Fire, fire.
This is really the beginning of the next space age. All of us have a part to play, and that's going to be the thing that blows the gate open to the next generation.
So inspiring. I can't wait to see where our shared curiosity takes us next. The Italian Air Force and the National Research Council have definitely used their curiosity to fuel their exciting experiments being conducted on board today. They are using the suborbital space lab to the fullest. One of the experiments being conducted on board today is the Neuroplasticity experiment. This is a passive experiment consisting of cell culture flasks containing human neural cells in cultures that will fly in a pocket of the researcher's flight suit. The experiment will test the ability to maintain stem cells in culture during suborbital flight and test the early effects of hypergravity, or high Gs, and microgravity, or low Gs, on neuroplasticity, which is the ability for cells to adapt to their environment. Data from this flight will be used for insight into physiology and pathology, but also be used to investigate biological processes for human spaceflight future missions and to study and develop new agents for therapeutic purposes for people here on Earth. Now, this is just one of many experiments on board for this mission the crew will be looking after. Maybe, JR, you could give us a quick overview of the profile?
Yeah, after release, the crew lights the rocket motor, and Unity's trajectory to space begins in that horizontal release position before turning towards space, a maneuver we call the gamma turn. The rest of the rocket motor burn will occur in the vertical, and everything after release through the completion of the rocket motor burn is called boost. Boost is only one of multiple phases of flight that our unique system experiences. After boost is feather. Now, sometimes when we say feather, we mean the tails of the spaceship, and sometimes we're referring to moving these tails into what we call the feathered configuration. It can be confusing, but I'll try to be clear what I mean when I say feathered today. So, due to the law of conservation of momentum, feathering the vehicle, that's rotating the tails to 60 degrees, causes the cabin of Unity to start a backflip maneuver as it approaches our next phase, Apogee. And this backflip is a key part of the experience because it maximizes the view of the Earth below. Our pilots use the RCS, that's a reaction control system, to hold the spaceship in that attitude. And then at the right time, the pilots will again use the RCS to continue that backflip all the way around. This prepares the vehicle for re-entry. In the feathered configuration, the vehicle presents a large area of the wing to the atmosphere, allowing our system to burn off energy while still high in the thin atmosphere. And then after re-entry, the feather is once again lowered and locked, turning Unity into a glider. It's in this configuration that the pilots will fly back to Spaceport America in what we refer to as the glide phase. You see, our system is capable of acting like a capsule when that's most beneficial, and acting like a glider when that's most beneficial. Now, MCC's in my ear, they're telling us we're 1 minute away from release. Our next set and our last set of checks before release are L-30, that's 30 seconds to release, and Spaceship Unity pilots will arm the launch pylon, and once we get to that designated launch point, the mothership pilots will engage the release, setting Unity free. Meanwhile, the spaceship pilots will push forward on the stick all the way, preparing for a release. We're now approximately 20 seconds from release. 10, 5, 3, 2, 1, release, release, release. Ignition. Good control. Trimming, that's pulling the nose up. And trim is set. We're now traveling at approximately Mach 1.4. There's max Q, that's the maximum dynamic pressure on the vehicle. Those on board are experiencing about 3 Gs at the moment. The trim is complete and Unity is in the vertical, headed toward space. Mach 2. Mach 2.8, rocket motor cutoff.
Amazing.
All right. Predicted apogee today is 275,000 feet. That's 84.3 kilometers.
Incredible.
Our mission specialists have been cleared to unstrap and enjoy the zero-G experience.
This is amazing. What you're seeing is Colonel Villaday going to the back to tend to the payloads that are mounted on the rack. You can see Landolfi and Leo starting their experiments in their seat and having, looks like, a great time, of course.
Yep. The feather is moving, as you can see. Starting that backflip maneuver I spoke of, the feather is now fully up.
Amazing. And viva la Italia! This is 100 years for the Italian Air Force. So happy centennial to the Air Force. This is absolutely incredible. And welcome to space, astronauts. How absolutely incredible. Benvenuto nello spazio. Congratulations to Walter, Angelo, and Leo on becoming astronauts today. And a special congratulations to our pilot, Nicola, for his first space flight. Welcome back to space, Mike and Colin. This is absolutely incredible.
Wonderful.
You can see I'm tripping over my words because I can see all the excitement here. And we've also trained our astronauts as part of our training program to, at Apogee, go to the window and take a look outside. So you're seeing them take a look and really reflect and take in the view, because all of the science and all of the research that they're conducting on board is for that vehicle, for that planet that they're looking out on. It's really that science and research being invested back into this planet, and it's important for them to reflect and see where their hard work is going.
Right. We have achieved apogee at 85.1 kilometers, or 279,000 feet.
Incredible.
The pilots are currently completing the backflip maneuver, orienting the vehicle for reentry. Now, just before 0.1 Gs, the pilots will give that return to seats call to the mission specialists. And our training team has worked this portion of the flight out so that it's very natural and intuitive for our passengers. You know, when we talk about space travel, a lot of people know and they expect the boost portion of flight to be loud and thrilling, and of course it is. But what's interesting is that the reentry is actually very similar. So as supersonic air flowing over our vehicle in the feathered configuration, shock waves form on top of the cabin, and those are audible to those inside. And for those of you on site here at Spaceport America watching from the ground, you should hear a double sonic boom as Spaceship Unity once again breaks the sound barrier. We're currently at Mach 2.5.
Incredible.
And just back to 1 G as we begin reentry.
And those views are just absolutely amazing.
Yes. So for reentry, we're now at about 3.6 Gs for those on board. The crew will orient the attitude of the spaceship so that when we come out of reentry and feather down, we'll be pointed toward spaceport. We're now subsonic and at 75,000 feet.
And the unique part of our design is as a vehicle that can get into this feathered configuration. We're a glider, we're a rocket, we're a glider, and we're a capsule at the right phases of flight that help our unique design be safe and effective for the mission it's at.
That's right. We're at 61,000 feet now, continuing to descend in the feathered configuration. When we get down to about 53,000 feet, the pilots will command lower of the feather again and reconfigure the vehicle back into a glider.
The views are just so incredibly amazing all the way down, and it's just part of each phase of flight has its unique experience. It has the ability to also conduct science. Our payloads that are on the rack are conducting and recording data all the way through each phase of flight. So you get hypergravity and low gravity data and that transition in between.
The feather is almost completed. The feather down. It is now down and locked.
Those watching from Spaceport America, now's a great time to go outside. Unity will be coming into view, and you can cheer on the crew as they return to Earth. Now, the mission specialists on the flight are supported by an incredible team on the ground from both the Air Force and the Center for National Research in Italy, who designed and developed the research being conducted on board. Space-based research is an incredible capability that is being opened up by suborbital vehicles like our own spaceflight system.
Landing approach. Tuning in, those numbers represent the first two numbers on a magnetic heading of the compass for the runway direction. So for example, 34 is 340 degrees. The landing gear is now down and locked. We have 3 green, that means all gear are down and locked. And we're making our final approach to the runway here at Spaceport America. We like to make left-hand turns for our approach. That's because the commander is in the left seat, and it provides the best line of sight for them as they come into the landing. Now, the runway here at Spaceport America is 12,000 feet long. That's 3.7 kilometers and 200 feet wide, or 61 meters. 1,000 feet above the runway. 500 feet. Over the threshold, that's the beginning of the runway. And you'll see the pilots hold the nose up. That's a flare maneuver, all part of the energy management. Main gear touchdown. So the pilots will continue to hold the nose gear in the air as we continue to bleed off some energy as we run down the runway. And at the designated airspeeds, they will lower the nose gear as well. Nose gears down. Now, as our ground speed slows, when we reach a designated ground speed, the pilots will apply the brakes and bring the vehicle to a complete stop. All right, braking now. And there's wheel stop.
Oh my goodness. What a beautiful landing and a perfect way to complete our first commercial flight and our first dedicated science mission. Congratulations to everyone on board.
We are grateful, of course, to the Italian National Research Council when we worked together for the experiment. And of course, we are grateful to our nations, Italy, to invest in this very important endeavor, and to this great host nation, the United States. We are very good partners and allies. So everything happening here has a profound significance for the bond, and the ties between the United States and Italy as well.
Incredible. Thank you to everyone on the ground here at Spaceport America who made this day possible. We cannot wait to hear about the experience from our mission specialists and to see the results of the experiments conducted on board. We will be continuing the celebration here as we await the arrival of all the other vehicles. Wherever you are on planet Earth, we thank you for watching. We'd love for you to join one of our upcoming future missions. Please join in on the celebration via social or head over to our website to learn more about this mission and how you can embark on your own journey to space. Ciao.
Ciao.